Hello everyone, welcome to the Blind 75 LeetCode question series, and let's continue with the next question, that is maximum sub array. Okay, now before going on, I would like to let you know that I have created this Blind 75 LeetCode question series. Apart from that, I also have LeetCode Medium and LeetCode Easy playlist available, so if you want, you can watch them. Now let's jump into the question first and understand what it is. And this is going to be a little longer video because we are going to cover two primary concepts over here. First is going to be a DP concept. Now before going on, this is just one thing that you should know. We are not going to cover DP in depth. Okay, this is just on a very high level. This is not at all in depth with the DP. Okay, just very small concept of DP that we are going to adopt in this question. And the second one is going to be okay, I will let you know when we reach over there. Okay, so let's focus on the first one. So before going ahead, what is the question? Yeah, so given an integer array nums, find the subarray with the largest sum and return its sum. Okay, now what is a subarray? Subarray, as they have given us, is a contiguous non-empty sequence of elements within an array. Okay, now what does this mean? So basically we have to find a subarray. Let me open up here. Yeah, so I have taken this particular array for example, which will be helpful for both the scenarios, both the solutions that we are going to code. So we have to find a continuous subsequence or a continuous sequence of an array which will give us the maximum sum. Okay, so in this condition, if you look here, 4, 6 and 3, if you do summation of these three terms, we will get the answer 13. Okay, so that is the maximum sum that we will get, maximum sub array that we will get. Okay, so the first one, it's going to look a lot similar to DP or memoization, or that kind of on that level. Okay, but that it is not exactly that thing. Okay, just if you are getting confused, and this is nothing like DP, this is just a small concept of DP that we are taking over here. So what is that concept I'm talking about? So basically the first step, first of all, we need a maximum sum, right? Okay, but how are we going to get the maximum sum? For that, what we'll do is that we'll go through our array, let's say -2, 4, 6, 3, -3 and 1 in our case. We'll go through this array, and for each term we'll check what is the current sum. Okay, now if I add current sum in this value, and if I don't add current sum in this value, which will give me the maximum value, maximum sum. Okay, maximum result. So this is, let's say this is a value. So either I can take current sum or I cannot take current sum. Okay, it's up to me, whichever gives me the maximum result. My value plus current sum. Okay, this is the concept of DP that we use generally. Okay, it may differ from question to question, but this is the basic thing that we use in DP. At every step we have options available. Either we can take or we cannot take. Okay, either we will take or we will not take. If we take, then what is the result? If we not take, then what is the result? And whatever we get, we will find the maximum from both of them. Okay, let's say this we will store back into current sum. Okay, and from this current sum we will find the maximum sum. I know it's a bit confusing. Let's look at the code, and then you will be able to understand it in a better way. So the first thing that we need is the maximum sum. Okay, instead of giving it 0, I will give it to nums of 0, because it is possible that we have only one element in our array, right? Okay, in that case we won't be able to compare it with anything else. And the next thing is that we'll require current sum, that is 0. Now what I'll do, I will go through this array Okay, what did I say? We'll find the maximum between what? At every position, I have two choices. Either I can take current sum, or I cannot take current sum. Either I will take current sum or I will not include current sum in my value. Okay, from this I will get the maximum current sum. Okay, and after this, what I will do, I will find the maximum between my current sum and my maximum sum, and I will return my maximum sum. Let's do a walkthrough if you did not understand this in here only. So we have -2, 4, 6, 3, -3 and 1. Let's say our current sum is like here 0 and maximum sum is -2. At each position I have two options. Either I can add current sum in this value or I cannot. Okay, so what is the value right now? -2. And what if I add current sum to -2? It's still going to remain -2. What is the maximum value right now? -2. Current sum, and current sum is going to be the maximum between current sum plus value and current sum. Okay, I'm sorry, current sum plus value and value. So right now the maximum is -2. Okay, what is the maximum between current sum and max sum? -2. Great. Now again we are at 4. I have two options: value plus current sum or value. This is going to give me 2, this is going to give me 4. Which is maximum? 4. So I will write it over here. Out of current sum and maximum sum, 4 is maximum. Now let's continue. So 4 and 6 or 6. Value or value plus current? Which is maximum? Value plus current. Current sum and maximum sum. Which is maximum? Current sum. Value plus value and value plus current sum. Value plus current sum is maximum. Current sum and maximum sum. Okay, again value or value plus current sum. Value plus current sum is maximum, and out of this 13. Value plus current sum, out of this 13. So we will get our final answer as 13. Now let me submit this and let's check if this is correct or not. And I hope it is correct. Yeah, so it is correct, as you can see. But why I'm saying this is good, right? We are good with this because if you will see, we have completed it in 1 ms runtime and it beats 100% and it is all good. But why are we looking at another solution as well? Since in the first video of this playlist, I had said that this will be helpful for you in your interview preparation, right? And in any interview preparation, you will always be asked follow-up questions. Similarly, here the follow-up question is that if you have figured out the big O of n solution, try coding another solution using the divide and conquer approach, which is more subtle. Okay, now divide and conquer, if you have not watched my video on binary search, okay, then I will give you the link in the description and you will also find it over in the I button. And it is better if you watch that. Divide and conquer will be very resolved for you. And another thing that will be helpful for you if you want to learn divide and conquer is to understand the merge sort. Okay. If you understand merge sort and binary search, then your divide and conquer, all your theories and your knowledge is completely good with this. So what is this divide and conquer approach we are going to follow? So I am taking into consideration that you have watched, you have understanding of divide and conquer approach, and whatever I say you will be able to understand. So let me start with divide and conquer. What are the steps that we are going to do? So as you know, in divide and conquer, what we do is that we divide our question into parts, okay, and we solve the smaller parts and then we integrate them. So in this situation as also, what we are going to do is that we are going to divide this array into two parts, the left part and the right part. Okay, and what we'll do is that we will find the maximum sum in the left and the right part. Okay, here also this is one array, so if we divide it again, this will look like this: -2, 4 and 6. Similarly 3, -3 and 1. Now what is the maximum in this? Okay, so if you will see, 4 is maximum, 6 is maximum, here 3 is maximum, 1 is maximum. But this is not how we are going to solve exactly over here. Okay, so what is the way, the exact way that we are going to use? This is basic divide and conquer, right? So what is the exact way we are going to use? So let me write it over here: -2, 4 and 6, 3, -3 and 1. So first of all, what we'll do is that we will find the left maximum sum. Okay, so what is the left maximum sum? Left maximum sum is nothing but the maximum sum in the left array, and right maximum sum is nothing but the maximum sum in the right array. Okay, so what is the maximum sum right now in this array? Okay, this is what, 6 and 4, 10. 10 minus 2 is 8. Now, okay, one more thing. Why I am going from right to left and not left to right? That is also one more thing to be considered over here, because the reason is that once I integrate this, okay, once I merge them back, just a minute, yeah, once I merge them back, they're not going to go in the reverse order. Okay, it is not going to be like 6, 4 and -2. They are going to be like -2, 4 and 6. And it is possible that your maximum sum that you're going to find, the half of this remains in the left part and half of them is going to be in the right part. So when you integrate them, you want to have a contiguous subarray, right? So for that particular reason, we are going from right to left. Okay. Now, so what is the maximum sum in the left part? 6 plus 4, 10. If we add -2, then it is going to reduce. So the left maximum sum is right now 10. Okay. Now again, we divide this: -2, 4 and 6. What is the left maximum sum over here? 4. If we go in the left direction, 4, it's already maximum. If we add -2, then it's going to be 2, which is smaller than 4. And for this, if we have single, it is going to be maximum. Now, one more thing that we need to check over here is that what is the maximum between this and this? Okay, what is it? 6. Okay, let's right now keep it that way. Same thing we are going to do it here: 3 minus 3, and this is going to be 1. This will give us 3 and this will give us 1. What is the maximum in this? 3. Okay. Now, one more thing that we need to take care is that this is the right maximum. Oh, okay, sorry. What is the right maximum sum? This is 3, right? Right maximum sum, it's 3. Okay. Now, one thing that we need to consider is that this is the maximum left part we can have. Okay. This is the maximum right part we can have. Okay, this is the left maximum sum and right maximum sum. Don't get confused over here. This is before dividing further. Left maximum sum and right maximum sum. Okay, this is 6 and 3. These are after dividing. So right now our left maximum sum and right maximum sum are 10 and 3. This is something that we have found in our left portion subarray. Okay. So what we'll do is that we will find what is the maximum in the left subarray. It is 6. Okay. What is the maximum in the right subarray? It is 3. And what is the maximum if we combine these two arrays? Okay. I hope you are understanding this. This is, please keep your attention over here. Okay. So -2, 4 and 6. Let me, okay, where can I remove this? Okay, never mind. So this, if I further break it down, then in n number of subparts, then the maximum sum that I can get is 6. Okay, if I break it down the right part n number of times, the maximum sum I can get is 3. But if I keep it as it is, minus 2, 4, 6, maximum sum is 10. If this part I keep as it is going to be 3. Okay, and if I combine them, I'm going to get 13 as my maximum sum. Okay, now we have to check which is greater. If I combine the left part and the right part, is that greater, or is the left part greater, or is the right part greater? Why I am saying this? So let's look at an example. Let's look 3 examples of why I am saying this. Let me remove all this first, and yeah, these as well, better. Okay, now the first example, let's say we have 2, 4, 3, minus 1, minus 2, minus 3. In this example, the left half will give me the maximum sum. Second example, if I reverse this, minus 1, minus 2, minus 3, 2, 4, and 3. In this particular example, the right half will give me the maximum example. Okay, in the third one, minus 1, 2, 4, 3, minus 2, minus 3. The combination, if I combine left half and the right half, that will give me the maximum result. Okay, so for that reason, we will check, are we getting the maximum in the left part, in the right part, or if we combine both the parts. Okay, these are the 3 things that we are going to take care. Now the explanation is over here. Okay, if you did not understand any of the part, I would suggest that you go back and you then watch the part which you did not understand, because this is really important. It will be really helpful to understand the divide and conquer approach. Okay, and also we will be using recursion over here. We have not seen recursion. Okay, but divide and conquer, it will almost all of the times it will use recursion. Okay, almost. There can be certain exceptions. Okay, so recursion will also be used. So if you do not have understanding of recursion, I will suggest that you go and you understand recursion. Okay, there are lots of videos and tutorials available on the YouTube. Okay, so now let's jump into the code and understand how are we going to do this. So what is the first thing that we are going to have? The function that is going to give us the result. Okay, so I will simply write it, return find max. Okay, I will name it as find max. It will take three parameters. First is going to be the array, second is going to be the starting index, and next is going to be the last index. Okay, now let me create this function as well. Find max int nums starting ending. Okay, in every recursion code that we do, we have one thing that common, that is the base condition. Okay, without base condition, if we try to do recursion, then it will go into an infinite loop. Okay, it will keep on calling itself. Okay, so the first thing that we need is our base condition, and that is going to be if our starting index is going to be equal to the last index. In that case, we'll simply return nums of start. Okay, that is if we have only one element. Okay, in that case the starting and ending index are going to be same. Okay, so the maximum sum is going to be that particular element. Next thing is that we'll find the mid, as we generally do in our divide and conquer approach. Now the formula to find the mid is a lot of people use different kind of formulas, but I use this particular one because there are less chances to go out of the range of our integers. Okay, and by 2. Okay, two things that we need over here. Third one will define it inside the loop. First thing is left maximum sum, and I will give it as integer dot minimum value. Okay, and right maximum sum. For that as well, I will copy this. Okay. Now, first of all, we will go through the left loop. Okay, left part of the array. Okay, so for that, if you remember, I said we will be going from right to left. Okay, so this is going to be starting from mid. And one more thing that we need is that we need to check at each position, we need to take care of the maximum sum as well, right? So for that, I will define maximum sum as 0 over here. Okay, I should be greater than equals to start, and I will decrement. Okay, max sum, that is going to be nums of I, and at each position I will check which is the greater one, sum and max sum. Okay, this is the left part. Now I will do this similarly for this same thing for the right part. Okay, a few things will change. I will start from mid plus 1. It will be less than or equals to the last position, and instead of decrementing, we'll increment this. Okay, left max sum, will rename it to right max sum, and it will find the maximum between right max sum and maximum sum. Now, if you remember, the left part and the right part is done. Now we need to find the maximum between these two. Okay, maximum between left part and the right part. So what we'll do, max left and right, that is going to be mat.max of what? The left part of the left part. Okay, we are continuing, we are doing recursion over here, right? So find max between what? Array is going to be the same. Okay, but the starting index, that is also going to be same, but the ending index, that is going to be mid, will only go till mid. Okay, and this is the left's left subpart. Now the left's right subpart, that is going to be find maximum. Okay, array is going to be nums. Okay, and let me do something, yeah, better. Array is going to be nums, starting index is going to be mid plus 1, and end it will at end. Okay, this max left and right will give us the maximum value between the sub array. Okay, we are doing recursion simply. Now our final thing, okay, we need to return what? First of all, the maximum between what? Now, as I said earlier, it can either be in the left part, in the right part, or in the center. Okay, the left and the right part is taken care by our this variable max left and right. Okay, but the combination, okay, where it can be in the middle, the maximum sum can be in the middle, that is taken care by left max sum plus right max sum. Okay, is it better? Can you see this? Yeah, I think so. Yeah, this is better, I think. Okay, and that's it. That is our code. I know it was a little bit difficult because we have not covered a lot of concepts and a lot of topics, but I will suggest that there are already a lot of tutorials and everything available on the YouTube and Stack Overflow and all that sort of websites and everywhere. Okay, so I'm not going into in depth of the concept right now. I'm just teaching you how we are going to use that concept and solve whatever problem we have in front of us. Okay, so our code is done. Let's submit this, and let's hope that I did not make any mistake. Okay, what is it? I is equal to mid, greater than equals to start. Okay, what is it? Expected. Okay, just a minor syntactical error. Okay, I ran this. Same thing over here as well, since I copied this. Now let me submit this, and I'm hoping there won't be any other mistakes. Yeah. So as you can see, we have also covered divide and conquer approach as well. This is a little bit on the costlier part as compared to if time complexity is taken into consideration. But since it was a follow-up question, it was helpful for us. It gave us a new understanding and some good knowledge. Okay. And yeah, so that's it for this video, and I hope you liked it and you learned something new. And do let me know if you have any problems for me to solve, and also do suggest me, like drop your suggestions or whatever in the comment box or whatever you want to do. Okay, so yeah, and one more suggestion from my end is that you understand these basic concepts of recursion, and we'll get into memoization and DP and all that. Recursion is like the first step towards DP. Okay, if you understand recursion, then you will be able to understand memoization and DP very easily. Okay, so yeah, thank you for watching, and I will see you in the next one. Till then, keep coding.